Hey, this is Sam Kristoff from samkristoff.com, and this is a video response to a question that Stock posted on the LabVIEW Maker Hub forums. And they're working on an application with an H-Brdige driving some motors. So they have an enable to control speed, that they'll use PWM to control that, and then direction output, both just digital outputs to drive the motors. And they wanted to go from full speed in one direction to full speed in the opposite direction. But I think they were using a conveyor belt, and switching speeds too abruptly was kind of too harsh of an acceleration for their application. So they're looking for a way to kind of ramp down from full speed forward to slowly go down to zero and then full speed reverse. So I've put together a little example program here using a state machine in LabVIEW to accomplish that. So let's dive in and see it in action first of all. So I'll click Run. And when I do, you can see I have a big gauge here that is indicating the speed between 0 and 1. So this is off to full speed. And a Boolean indicator, an LED that indicates the direction. So off I use to represent reverse, and on for forward. I'm using a state machine, and I'm just displaying the current state that we're in. I have 3 buttons, reverse, idle, and forward, to control, just manual control of the states. And then a graph to indicate the current speed, and it goes from, we'll go from 0 to 1. This takes direction into account, so you'll see a negative speed when we're in reverse. So I will go ahead and click forward, and you can see we slowly ramp up to full speed, which is 1, and a positive forward direction's on. If I click reverse, it'll ramp down through 0, the direction changes, and now we're at -1. I'll click that again so you can see how we go speed down to 0, then the direction changes, and then speed back up. And if I click idle at any point, it'll return to the point that it's in. It'll return to 0 rather. If I click forward and it's not quite done, I can click reverse and it'll transition between the points. So any state that you're in can transition to any other state at any given time. So I'll stop that and let's take a look at the code. Like I said, I'm using a state machine, so you can see I have a big outer while loop, and I have a case structure inside the while loop that's going to execute different cases depending on what state you're in. I have 3 shift registers to store variables between each loop iteration. One that stores the current speed, another that stores the direction, and another that stores the state. I have 6 total states: idle, which is the state we start in, accelerate, full forward, decelerate, full reverse, and stop. So the idea is that the idle state is we're not doing anything, we're just sitting at 0. Accelerate is when we want to increase our velocity. Full forward is when we're at the maximum speed moving forward. Decelerate would be when we need to decrease our speed. And this is just decrease the absolute speed, so this doesn't take into account forward or reverse. Then we have full reverse, so this is when we're full speed now in the opposite direction. And then we have a stop case, and this is where we want to go from any point that we're at, any speed and direction, back to the idle state. In order to accomplish all these states, I have a case structure over here, and you can see we have a case for each of those states. So in the idle state, like I said, the speed output is set to 0, and the direction doesn't really matter in this state, but we just default it to false. In the accelerate state, we've defined a max speed and an acceleration, and we take the current speed, so C pass through on this shift register, current speed, and we add that acceleration. Right now that's set to 0.001. So we're adding 0.001 every time this accelerate state executes. And then we're checking to see if that acceleration has exceeded our maximum speed. And that right now is just set to 1. If it has exceeded the maximum speed, that means that we are at full speed. So we've been accelerating, we're now at full speed. And then based on the direction, we're either going to go to full forward or full reverse state. So again, this accelerate state doesn't take into account the direction that you're going, just the speed. We look at the direction to determine if it's full forward or full reverse. If you're in the accelerate state and you haven't exceeded the max speed, then you just stay in the accelerate state and continue accelerating. The decelerate state is basically the same thing, except we're subtracting from the speed and checking if it's less than or equal to 0. If it is less or equal to 0, then that means that we've reached 0, and so we can start accelerating in the opposite direction. So we change the direction, set the speed equal to 0 so we don't start negative, and change to the accelerate state. If we're not less than or equal 0, we just stay in this decelerate state and continue decelerating. The stop state works basically the same, except when we get down to 0, we go to the idle state. If we're not less than 0, we just keep decelerating. So basically, rather than going to accelerate in the opposite direction now, we just move to the idle state. Then the full forward state, we don't need to do anything because we're using this event structure to watch for user event changes. So if we're going full forward, we just stay at that speed. Full reverse, same thing. Nothing to do here. We're just going full reverse until something causes us to switch states. Now we'll look at the event structure. And you can see that I'm using a timeout case here to just pass everything through, and we have a timeout of 0. So that means that the event structure won't block. It'll just immediately execute this even if no user event or if no events have taken place. And we have a delay of 1 millisecond, so our loop will iterate at about 1,000 times a second. The forward value change, so we have our forward button here. We have a value change event. And the first thing we do is set the value to false. So this is basically depressing that button. And then we're looking at the speed. If you press the forward button, we look at your speed and direction. If your direction is false and your speed's greater than 0, that means you're moving in reverse. So rather than just switch to moving forward, we have to decelerate first. If that's not the case, then that means you're either stopped or moving forward, in which case we can just start acceleration immediately. And you can see we set the direction to true in this case, and we leave it like it is in the other one. So again, if you're stopped or already moving forward, it's safe to just move forward in the accelerate state. Otherwise, we need to decelerate to 0 and then speed back up in the other direction. So as you can imagine, reverse is basically the same thing but the opposite. So we look at the speed and say if the speed is greater than 0 and you're moving forward, then we need to go through the decelerate state. So in order to move in reverse, we decelerate down to 0, and then we'll accelerate up in the opposite direction. And again, in the false case, this means you're either stopped or moving in reverse, so we're just going to accelerate. So let's jump back to the front panel and see it in action again. So right now I'm in the idle case, so basically nothing's happening until I get some user input to change that. When I click forward now, this case is going to execute, and it'll see that I'm in the idle state, so it knows that I can immediately start accelerating. I don't have to decelerate before I start accelerating. So it'll set the direction, and it'll set the state to accelerate, and then the accelerate case will start adding values until I hit that maximum acceleration. So let's see that. I'll click forward, and you can see the speed accelerates, the direction was immediately turned to true, and my speed ramped up. Now, in this case, I'm going to hit reverse. So if I hit reverse, we'll look at the speed and say the speed is certainly greater than 0 because we're moving full speed forward, and the direction is forward. So we're moving full speed in the direction that we don't want to be going. So in that case, we need to decelerate. So we leave the direction the same and start decelerating until we get down to 0. At which point we will switch to accelerate and change the direction. So again, we're checking the speed to see if it's less than or equal to 0, and then we'll switch directions and start accelerating. So I'll click reverse, the speed decreases to 0, direction changed, and then the speed increased back up to 1. So it's a fairly complicated state machine, especially since we need to be careful about not only the states we're in, but the transitions. So if we transition from idle to full speed forward, that's easy. We just start going full speed forward. But if we're already going full speed reverse, we have to be careful because from that state to full speed forward, we need to go through the decelerate and the accelerate states rather than just to the accelerate state. I hope that quick overview was helpful. I'll post the code below and make sure to post if you have any more questions. Thanks for watching. Make sure to subscribe to get updates on all my latest videos, and check out samkristoff.com for an archive of all of my projects. You can find the source code to all my projects on github.com/samkristoff. If you have any questions, feel free to post below or tweet at me at Sam Kristoff.